Hi 6th graders, today we're going to be taking a look at sequences. By the end of this lesson you want to be able to extend and describe arithmetic sequences using algebraic expressions. So the table to the right shows the number of slices of pizza you get depending on the number of large pizzas that you buy. I want you to go ahead and pause the video and see if you can fill in and answer these questions on your own using what we know about proportions and such. So we want to find the ratio of slices to the number of pizzas for each row of the table below. So if you notice, we're doing slices to pizza. So we have 8 slices for one pizza, 16 slices for 2, 24 for 3, and 32 for 4. So is the number of pizzas proportional, or number of pizzas proportional to the number of slices? Why or why not? Hopefully you said yes, because if you look at all the previous ones, they all can simplify to the same ratio of 8 slices to 1 pizza. So now we want to make a list of the number of slices and describe the pattern between consecutive numbers on the list. Some of you might be saying, well, what does consecutive mean? Consecutive means like numbers that come after each other. So typically when you think of consecutive numbers, an example would be like 1, 2, and 3 would be consecutive. So they're just numbers that are next to each other in a pattern. So we're just looking at the number of slices. So it's 8, 16, 24, 32. So now I want you to look at those numbers and see if you see a pattern between each of those numbers. So from 8 to 16, 16 to 24, 24 to 32. Hopefully you see that each one increases or adds 8. So we see a pattern of adding 8 to the previous term. Term refers to a number in the pattern. So 8 is the first term, 16 is the second term, 24 is the third term, and 32 is the fourth term. So what relationship seems to exist between the pattern found in number 3 and the ratios found in number 1? Well, each time here we are adding 8, and then if you look at the ratio that we simplified to in number 1 and number 2, it was 8 over 1. Well, 8 divided by 1 is 8. So the number added to each term is the same as our original ratio. And we're going to explore this more as we move through. So let's get to the nitty-gritty a little bit more. So a sequence is a list of numbers in a specific order. Now, sequences can come in lots of different orders, but there has to be some sort of rule or pattern to them. A term is just a number somewhere in a sequence. An arithmetic or arithmetic sequence is a sequence in which the difference between each term is found by adding or subtracting the same number, and that number is called the common difference. So I want you to look at this pattern and I want you to describe the sequence. So 2, 4, 6, 8. If we look, each term is 2 more than the previous term. So we would add 2 to the previous term. That would describe our sequence. We can also write an algebraic expression or equation to describe the sequences as well. And the reason that we would do that is when we're looking for situations where, like in this next example, we want to find the 30th term. Well, I know I personally don't want to sit there and add 2 a bunch of times to get to the 30th term. So this is where going back to our tables help. So we're going to call x our term number, okay, and y is going to be our term. So x just means where it is in the sequence. So for example, our first term is 2 because 2 is the first number in the sequence. Our second term is 4, our third term is 6, and our fourth term is 8. Now what we're going to look at is we're kind of going to look at our pattern that we found where the adding 2 and look at the relationship between x and y. Now you might notice that 1 plus 2 does not equal 2. But what can I do to 1 to get to 2? Well, you might find that y, our term, is equal to 2 times our x value. In this case, the 2 was our common difference. So if you look here, 2 times 1 is 2, 2 times 2 is 4, 3 times 2 is 6, 4 times 2 is 8. So this pattern, or this equation, would work, and it's an equation because we have an equal sign. So now if we want to find the 30th term in this sequence, it's really slick because we can take this equation that we made. Since 30 is the term, remember term is our x, I can put 30 in for x. So this is going to be y equals 2 times 30. So y is equal to 60. So our 30th term in the sequence would be 60. Now when the directions say to use symbols, really what they're asking you to do is write an equation. To describe the value of each term as a function of its position, and then find the value of the 20th term in the sequence. Alright, so here we didn't start with the first, second, and third term in the sequence. We're actually starting with the 10th, 11th, 12th, and 13th. N is often used instead of x to find out the common term. So this is going to be our n, and then this might be like our y, but n is really the same thing as x. So I'm going to look at what can I do to n to get my y term. Okay? So here, what can I do to 10 to get 7? Well, we might take the n and minus 3. So let's look. Let's look at our next number in the sequence, which would be 11, and check if, which would be 8, and see if I can do that same thing to 11. So 11 minus 3 is 8, 12 minus 3 is 9, 13 minus 3 is 10. So this would be an equation that would describe our sequence. Now because we want to find the 20th term, we're going to go ahead and put 20 in for n, so y equals 20 minus 3. So the 20th term in the sequence would be 17. Now I want you to pause the video and just try the next one on your own. It might be a little challenging, and that's okay, but I just want you to try something and see what you come up with. So once again, remember our position is our n. Our value of our term we're just going to call y. So what am I going to do to n to get my y term? So for example here, what can I do to 1 to get to 4? Well, if you think of like the previous one, maybe I'm going to add 3. Okay, so then I'm going to look at my next number, which is 2. 2 plus 3 is 5, but our term is 7. So that means that n plus 3 wouldn't work. So what's something else that I could do? Okay, well, 1 times 4, so maybe this one's going to be 4 times n. So let's look at our second term. So 2 times 4 is 8. Uh-oh, our second term is 7. So that one's not going to work either. If you go back to what we were originally doing on the first slide, remember we were just looking at the sequence, which is the value of the term. So let's just look at this as a sequence. So we have the sequence 4, 7, 10, 13. What do you notice about each of these terms? Each of them increases by 3. If you remember with our original pizza slices, our equation was y equals 8 times the number of pizzas. because it was 8 slices per pizza. So like for example, if we had 1 pizza, it was 8, 2 pizzas was 16, 3 pizzas was 24, etc. 8 was what was being added to each term to get the next. So I'm going to start with that this time. So in this case, it's going to be y equals 3 times n. Now you might be saying, wait a minute, Mrs. Whitney, that doesn't make any sense, because if I multiply 1 by 3, my answer is only 3. Sometimes, however, sequences have a hidden pattern to them because we're not just doing a single function to them or a single operation. If I take 3 times n, I would get 3, but my value of my first term is 4. So now we're going to look at our position as this number instead of the original 1 here. So what can I do to 3 to get 4? Well, I can add 1. If you notice, our function's a little bit different now because there's 2 operations. There's multiplication and addition. But we want to check if that works. So I'm going to look at my second term. So y is going to equal 3 times 2 plus 1. 3 times 2 is 6, plus 1 is 7. That works for the first one. Let's try the third one. 3 times 3 is 9, plus 1 is 10. 4 times 3 is 12, plus 1 is 13. So this actually ends up being our equation for our sequence. Now we want to find the 20th term, which means I'm going to put 20 in for n, so it's going to be 3 times 20 plus 1. 3 times 20 is 60, plus 1 is 61. So our 20th term is going to be 61. I know a lot of you are probably super confused by this last one. That's okay. That's going to happen. Just make sure that you write down any questions on Edmodo when you're done watching. And we can talk about this more tomorrow.